What's mu again for NPQ problem? NP. And what's the standard deviation? Now, let's talk about what that P symbol and the Q symbol really means. P is population percent success. And Q, of course, is population percent failure. So just like with means, I have the Greek letter for population mean, and then I have X bar for sample mean. Right? So here I've got to have symbols like that. I have P for population success rate. So what am I going to use? I'm going to use something very funny. It's not my creation. I'm going to use something called P hat. Article of clothing you don't want to wear is the P hat. This is sample percent success. Yeah, so if I said, I take a sample of 87 and 30% of them passed the test, 30% is P hat. Because it came from a sample I took. Okay. Maybe. So what's going to happen now? So the mu for the sample I take is going to be n times P hat. Amazing so far. And then what's going to happen with sigma? What's it going to be? It's going to be square root of. You can do it. All that changes is what? So n, P hat, Q hat. And no matter what article of clothing they're wearing, P plus Q must be 1. So P's and Q's wearing hats, they still have to add to 1. They're still percentages, like always. Stay with me now. So this, right now, just to remind you, we are in the construction of a formula phase right now. You're never going to use this formula ever, because we haven't figured out what formula I want to use. Is this going to give me a confidence interval for percentages? No, this is still going to be an average number of things. So what do I want to get rid of? I want to get an interval for percentages. So I want to get rid of the stupid n. If that wasn't there, it would be a percentage give or take something. Right? Yes, okay. So let me help us out a little bit. I'm trying to get an idea of the real mean with this, right? The same way that this is trying to get an idea of what the mean is. So the mean is approximated by this. So the mean, NP, is approximated by that interval. So now I've kind of set up sort of an equation for myself. So how do I get just what approximates P? I divide by N. So now I have like 40% give or take something. Now this is going to be like those reports of polls when there's an election coming. 40% want to vote for this guy, give or take 4%. What the shit? So here's the key thing. What can I do with this? Can I kill the N's? Just cancel them?
Yay!
No. There isn't an N up top. There isn't. There's half of an N up top, right? I know. What's another way to write N? So really, what's the most direct reasoning why I can't cancel these? Because they don't have the same root. So what's N equal to the square root of? So I haven't changed anything, right? N is the square root of N squared. But now I can reduce these, because they both have a root. You guys remember that? You can't divide unless they have the same root. So, oh, I can see people. Hey, people. What happens here then? An N cancels. So you end up with, this is the confidence interval formula. This is one we're going to use for a percentage. So it's a percentage, give or take something. You make one big ass square root. There it is, just. That looks like the zth root. Sorry. Yeah, let's not do the zth root. So it's still a percentage I get from a sample, give or take this much. This is still the error, everything's still the same. I still get z-scores the same way as before. When won't I be able to use this if this isn't met? Then I can't do shit. This has got to be true in order for me to do this at all, because the z-score is the main important part of this whole thing.
So this is supposed to be approximating the probability of success in the population.
Exactly. So that's what that is, right? The same way when I constructed a confidence interval for a sample mean, it's supposed to give me an idea of where it looks like the real mean is. This is supposed to give me an idea of where the real percentage is. So let's try a problem out together. What time is it? All right. So say I talk to, what you gotcha? 89 people. And 53 of them are excited about season 8 Game of Thrones. If you don't know what GOT is, then that's fine, actually, I guess. You've probably not wasted as much of your life as some of us have. Now, and then I just say, let's construct a 99% confidence interval for the true percentage excited about Game of Thrones coming. Game of Thrones is coming. So the thing about percentage problems is it kind of, to me at least, feels like they don't give me enough information. There's very little information that they have to give me, because I construct everything I need from some basic things. What the shit is p hat from this problem? Yeah, 53 out of 89. So p hat is the percentage I see in my sample. So it's always going to be a ratio of x to n, successes divided by total. 53 successes divided by 89 people, and then whatever the hell that is. I have zero idea. 3. It's like 0.57? What is it?
0.596.
0.596? Beautifully done. For p hat and q hat, it's got to be at least 3 places. And do you remember? Is it 0.596? Is it cool? Yeah. Do you remember earlier this semester when I said if you just take everything to 4 places, except z-scores, you'll be covered? So same thing here. It's got to be at least 3, just like standard deviation. Take it at least 3 places. What's q hat then? What's q hat? It's just going to be 1 minus this, right? The rest of it. 404. 1 minus that. Is that cool? Or you can do 89 minus 53 divided by 80. Well, you can just remember that these two have to add to 1. Okay, I like it. What do I check to make sure I can do that formula now? What do I have to check? Yes, NP hat and NQ hat. Now some of you guys, hope to God, some of you guys get this. How did I calculate P hat? Wasn't it this divided by N? Right? P hat was X divided by N. X is the number of successes. So what will N times P hat always be? Whatever the hell that number was, right? So you can either multiply 89 times 0.596, or you can realize that 89 times this divided by 89 is just this. Is that bigger than 5? Or at least 5? Yes. So what's NQ hat going to be? The rest. 36. And that is at least 5. All right, I like it. And what does that do for me? That check, what does it tell me? I can use it because that tells me it is normal enough. Same way that n greater than 30 used to tell me that means distributions were normal enough. Okay. So what's the only thing I don't have that the formula requires for me? Z. I got everything else. So how do I get Z? What piece of this is going to help me get Z? Yes. It always comes from how confident I want. The one thing that sucks about percentage problems is that's a percentage and so is everything else. Shit. So people get a little confused. The only thing this does is tell you what Z is. That's all the level of confidence ever does. If you use a little baby chart, what do you get for 99%? Yeah. So let's summarize what we know here. We know p hat. We use a better marker. Is the other blue one better? P hat was 0.596. Look at you. Q hat is 0.404. N was 89. Z is, what was it again? 2.575. And now I've got everything I need just to throw in that formula. 0.596, give or take this many of these. Got it. One of the biggest mistakes is people put 53 there. Doesn't make any sense. N is always the total number. This also sometimes presents a challenge for people to plug it in their calculator.